Hey everybody, this is Mr. Kinney. I'm going to go over the volume problem before I go over the mass problems with you. I just recorded the answers for the mass, and that was like 30 minutes, and I got talking about some other stuff. And so I want to get this for you first so that if you've got the mass problems, you can be working on this. So when you put the paper over here, you just got to remember, and this is actually take 2 because when I first read the problem, my brain spun a little bit and I realized, hey, they just gave us some extra information we don't need. So one thing you got to remember, let me zoom in, I'd like you to put this near the top of your paper, is that when we're working with gases, 1 mole of any gas, and I've got this written up here for you, 1 mole of any gas will equal 22.4 liters of that gas, and that's at STP, standard temperature and pressure, which works out to be 0 degrees Celsius and 1 atmosphere. And 1 atmosphere is, if you're at sea level on a 70-degree day when there wasn't a storm coming or going, that would be 1 atmosphere. So it's a measurement of how much pressure. So when we work on these problems, we're just going to be looking at the molar ratios, and instead of using Avogadro's number or the molar mass, we're going to be using 22.4 liters as our conversion. So when I read this problem, let's read it through. What volume of hydrogen is necessary to react with 5 liters of nitrogen to produce ammonia? Now, they're talking about 3 things in there, but what they're asking us for, what volume of hydrogen is necessary to react with 5 liters of nitrogen? 5 liters of nitrogen is what they're asking us to convert. That's our given. And what volume of hydrogen? That's what they're asking us. They're asking us to find out the volume of hydrogen. So let's put liters of hydrogen. Now, hydrogen in this problem is in the form of H2. So we're just going to put liters of hydrogen just to make sure that we, you know what, I'm going to write out liter just so we don't get it mixed up with something else. So we're looking for liters of hydrogen. And yeah, it's going to produce ammonia. Now, that can kind of throw you, but remember in these problems, what's the given and what do they want you to convert? The given is 5 liters of nitrogen, 5 liters of N2. Now, nitrogen gas is N2. Okay, and if you want to put an S, 5 liters, that's okay, all right. So we're going to set up our dimensional analysis conversion chart. Second greatest invention since ice cream. Now what we want to do is we need to get we want to get this over into, we want to find out the nitrogen over here. So what we need to do is we need to get this into moles of nitrogen because it's the moles that will allow us to do the proper conversion. So since our conversion factor is 22.4, in fact, you know what, at the top of the paper, let's write this up here just so you know. We can have 22.4 liters is 1 mole, or 1 mole for every 22.4 liters. Okay, so that's our conversion. And since we have liters up here in the numerator, we want to get liters of nitrogen down here in the denominator. So we're going to say that 1 liter, excuse me, no, I made a mistake. 22.4 liters, because remember, anytime we're using liters, we got to use the 22.4. 22.4 liters of N2 is 1 mole of N2. So now, liters of nitrogen have canceled with liters of nitrogen, and now we have our old friend the mole back, and now we're comfortable with working with moles. Now we got to set up a molar ratio over here. So when we look back at our problem, we'll take a look over here. We have 1 mole of nitrogen with 3 moles of hydrogen reacting to make 2 moles of NH3, ammonia. Okay, well we want to get rid of moles of of nitrogen right here, and there's only 1 mole of nitrogen in the problem, so we put 1 mole nitrogen. And since we're looking for H2, hydrogen gas, there's 1 mole of nitrogen for every 3 moles of H2. So now the moles of nitrogen can cancel. And now we've got moles, at this point in the problem, we've turned this into moles of hydrogen, but we're looking for liters of hydrogen. So we're going to use our conversion up here, but now we're going to use a different conversion. We want to get rid of, we want this one right here, because we want to get rid of moles. So there's 1 mole of H2 in 22.4 liters of H2. Those cancel out. And so now what we get here, we've got 22.4 liters. Well, that's all right, but look, at 22.4 can cancel with this 22.4, so we don't have to mess with that. And there's nothing else that we can cross-cancel in this problem. So what it becomes is 5 times 1 times 3. Oh, and I'm sorry, this should have become, when we canceled these, those just became 1 and 1. So 5 times 1 times 3, 5 times 1. Well, that's just 5 times 3. 5 times 3 times 1. Okay, we don't need to mess with that. And this is just 1 times 1 times 1. So our answer comes out to be 15 liters of H2. Liters of H2. There we go. Now, for number 2, what volume of ammonia is produced in problem 1? Now, you've got a choice here. You can either use 15 liters of H2 as you're given, or you can do what we had over here, you can do 5 liters of N2, and then we just set up a different molar ratio. So I would suggest that you've got a choice. So we can, for this problem, you can set up 5 liters N2, or if you want, in fact, actually, I'm going to have you practice both of these, but doesn't matter to me. I think we'll just start with 5 liters of N2 in this problem, and that's what I'd recommend. But you could just as easily, if you wanted to, you could make your given 15 liters of H2, because as we work through the stoichiometry, what's going to happen is we're going to end up with the same answer. There'll be different ratios and numbers. So start with that one. 5 is easier than 15. Down here, now in this problem, what volume of ammonia is produced? Okay, so we're looking for liters of ammonia, NH3, in this problem over here. So let me zoom out so you can see the screen better. Okay, so we're looking for liters of NH3 over here. So we want to make sure we find that. And that's going to be using the equation up here. And let's see, this one right here, we have a combustion problem. So we've got 20 liters of oxygen are consumed. We have a typo, sorry about that. That should be consumed in the above reaction. How many liters of carbon dioxide are produced? So in this problem, what's given is 20 liters of oxygen, 20 liters of oxygen, O2. So that's our given. I'll help you out there. And then how many liters of carbon dioxide are produced? So we're looking for liters of CO2. So always set those up to make sure you get these right. In this problem here, we've got 30 milliliters of hydrogen are produced with the above reaction. Now in this one, because there's milliliters, to do the full stoichiometry, you need to know this conversion factor, and you may not know that, but 1,000 milliliters are in 1 liter, or the opposite, in case depending on 1 liter is equal to 1,000 milliliters. So when you do this problem, what you're going to have to do is you're going to have to convert. You're going to have to start off by doing. We have 30 milliliters. I'll use the M capital L that they gave in the problem. Milliliters of hydrogen, and that's going to be H2. Well, let's just get it back to liters. So we know to get back to liters, there are 1,000 milliliters in 1 liter. Oh, I should say milliliter H2 in liters of H2. So now at this point, now we're at liters of H2, and we'll go on. Now at the end of the problem, we'll have to rotate this back and turn it back into liters. So this one, instead of being a see, 1, 2, 3-step problem. It's actually going to come out to be a, let's see, a 1, 2, 3, 4. We'll have 5 steps, because once you end up near the end, you're going to have liters of, and in this problem, we're looking for how many liters of oxygen. Excuse me, milliliters of oxygen. Let's get that set up right. And one of the last conversions you'll be doing is just the one where you're going from liters to milliliters at the end. So don't let that scare you. And then in this problem right over here, how many liters of carbon dioxide are produced? So they're looking for liters of CO2 if 7.5 liters of propane are burned in oxygen. Okay, now there's another part to the problem. That's going to be part 2 to this problem. Just leave it for the moment. Okay, right now we're going to solve, this is like part A, this is like part B. We're just working on part A now. So for part A, we're looking for liters of CO2, and we're given 7.5 liters of propane, C3H8. Okay? So get working on that. And then when you do part B is looking for how many liters of oxygen. So liters of oxygen for part B of this problem. And you'll set it up the same way. This is your given. You're just going to be looking for, instead of CO2, you'll be looking for oxygen. So this will be homework for you to get these set up for when I see you next on Wednesday. Bye.